Thank you for joining us at AWS reInvent. The name of this session is Uplevel Your AWS Infrastructure Automation with GitOps, with myself, William Chia, and my colleague, Brendan O'Leary. So my name is William Chia. I serve on the product marketing team at Git Lab, and you can find me in various places online. I'd love to connect with you or see any tweets from you while you're watching the talk. If there's anything interesting, go ahead and reach out to us on Twitter, and we'll be happy to respond to you there, as well as within the platform. And I'll pass it over to my colleague Brendan to introduce himself.
Great, thanks, William. My name's Brendan O'Leary, as William said. And yeah, I think Twitter is probably the easiest way to get in touch with me. So if you have questions during or after watching this session, please reach out to me there. I'm a senior developer evangelist at GitLab, and I'm really excited to talk to you all today about how you can make GitOps work for you.
So as a way of introduction, the landscape of software, it's always changing. If we just look at some of the recent ways the world has changed, we've gone from waterfall to adopting agile with smaller changes, adopting DevOps as automation, and now moving into a world of cloud native, where we have dynamic environments that scale up and down, distributed microservices, and all of this is to serve users that are expecting always-on applications that are available from any device. And in order to keep up with all of this very, very rapid application development, we need an infrastructure methodology that can manage all of that complexity. And this is where GitOps comes in. So at its core, GitOps is an operational framework that takes DevOps best practices, things that we use for app dev, like version control, collaboration, compliance, and CI/CD, and we're going to apply them to the realm of infrastructure automation. So as a methodology, there's not any specific technology you need, but I'll tell you what GitOps is, and then we'll show you a demo. At its heart, GitOps is infrastructure as code, plus merge requests as your agent of change, plus CI/CD. And I'll briefly touch on what each of these are: infrastructure as code, MRs, and CI/CD, the main components of GitOps. The first thing we need to do is we need to store our environments as code in a Git repository. We're going to use the term infrastructure as code, but you could talk about X as code because this could be configuration, policy, or any type of operations, but we're going to use IAC X as code. Very often, this works really nicely with declarative state tools. So you can use this with procedural tools, but declarative tools, things like Terraform, like we'll be using in this demo, work really nicely with GitOps. We're going to store them in Git version control. And what this allows us to do is use Git as the UI in order to access our operations, rather than using a manual interface or disparate interfaces. We have one interface, and it's our Git tooling. Now, with GitOps, we don't want to make any manual edits. We want our edits to be automated. And so the structure we're going to set up, and we'll show this to you in the demo, is we want a branch that represents an environment. And we want all changes to that environment to be proposed as merge requests to that branch. In some tools, in GitLab, we call this a merge request or an MR. In some other tools, it's called a pull request or a PR. But the concept is the same, that this is the gate that is a proposal of any changes. It's your central point of collaboration, and then you can merge that back into the branch. Finally, we don't want to make any manual updates to our infrastructure. We want to automate it all. So our CI/CD is going to run as a type of automated reconciliation. Whenever there's a new change in our Git repo, CI/CD is going to apply that automated change. There's a couple different ways you could do CI/CD. There's agent-based, where an agent runs in your Kubernetes cluster and it pulls and changes. For us today, we're going to be using agentless GitOps or push-based GitOps, where our CI/CD pipeline will kick off when we merge and is going to push our changes into our Kubernetes cluster. So without further ado, let's just take a look at what this looks like in practice. So here's maybe a common scenario that you have found yourself in before. You are logged into your AWS console. Let's say you have a Kubernetes cluster and it's running on EKS, and you have a node group assigned to that cluster. And maybe you need to migrate some workloads off of a different cloud onto AWS. And in order to accommodate the migration of the new workloads, you want to expand the capacity of the cluster. Well, one of the ways I could do this, of course, is I could just go into my node group here and click on edit and just manually increase the capacity of my cluster and click to save the changes. But this has a few problems with it. First of all, how do I propose this as a change and get feedback on it without enacting the change? There's not a way for me here to say like, well, I think this is the change should be. Can I get some peer review? Can I get some feedback on this and some collaboration? There's no way for me to loop in other stakeholders and show them the work that's happening. This is completely opaque for my development team, so they don't know if the infrastructure is ready for them to be able to deploy to. This has challenges with compliance and auditing. I don't necessarily have a central point where I can see all of my changes taking place. I have to go and look in my different tools and my different services and try to composite those together in order to find an audit log of all of my changes. So because of these collaboration challenges and because of these compliance challenges, instead, we're going to do the same change, but we want to do it with GitOps. So here is our demo GitOps group within GitLab, and I'm going to just show you the structure here. We've got a group set up for our infrastructure, and we'll show you first how it works, and then we'll walk through a few of the code samples. So in our GitOps group, we have an AWS group that's going to host all of our AWS code. We have a templates group, which is going to allow us to write a pipeline once and use it for any cloud in a multi-cloud application. And we have a GCP group where we want to migrate our workloads off of the GCP cluster onto the AWS cluster. And we also have an apps group. And so this is where we have various sample applications written in different languages. And today we're going to show what it looks like when we want to migrate our Node application onto AWS. So in the part of this demo, I'll be playing the part of the platform engineer who does the work. And my colleague Brendan will be playing the part of my manager who is doing the planning and the overseeing. So with that, let me hand it over to Brendan, and he'll show you how in an infrastructure group, we would start planning for this type of change.
Great, thanks, William. And yeah, so as William said, I'm going to put on my engineering manager hat here. And I'm going to say that we're working on a migration of many of our apps into this EKS cluster. And so to handle that, at first, I'm going to go to the infrastructure project and open an issue there to increase the capacity. So if I just go to this project here, I can go to issues. We can see there's none open right now, but I'm going to open a new one and say increase max capacity of the cluster. And then I will assign that issue to William because I know that he's going to be the one doing the work. And so that'll help us in our infrastructure add that capacity as code as William was talking about. But I'm also then going to go to the Node app, which is the next app in line to be migrated, and add an issue here to, once that capacity is ready, go ahead and migrate this app to the EKS cluster. I'll also assign that to William. And now we have those two issues, one to increase the capacity of the cluster, and one to migrate the app once it's available to that new capacity. And now I will give it back to William to show us how he's going to make that work happen.
Thanks a lot, Brendan. So here I am again in the GitOps group, and I'm going to go over to my infrastructure group, and I will look at my issues list. And I can see here there's an issue to increase the max capacity for the cluster. Similarly, I can go to the apps group and go to the Node app. And I should be able to see an issue here to migrate this app to the EKS cluster. So the first thing I'm going to do is I want to attack this migration issue. And what I'm going to do is the very first thing is I'm going to click on this button here to create a merge request. I'm going to do that directly from the issue. And the reason why is I'm using something that we call Git Lab Flow. Now, in your workflow, you may be used to doing something like when you're going to go start work on a task, you start a local development branch on your local machine. and you would add some commits to that branch and maybe clean up the history and then push it remotely. And instead here, we're creating essentially a branch that's empty with no changes and starting with an empty branch and then adding changes to it. This is what we call Git Lab Flow. And the reason we do this flow with starting with a branch is because right from the get-go, we have a central point of remote collaboration. So you see, if I just started a branch on my local machine, then no one else can see the progress. No one else can see what I'm doing. But if I start work remotely on the remote, not necessarily on the remote branch, but if I start with an empty MR, any commits I make to that are immediately seen by colleagues and stakeholders and peers. So they can keep track of the work that I'm doing. They can see progress on it. It's more transparent and allows for more collaboration. So this is why we start with the empty MR. The next thing I want to do is I want to open the web IDE. I could check out this branch and do the changes locally, but in this case, I'm just going to use the built-in web IDE that comes with GitLab, and I'm going to look here at the pipeline. So I can see that this app is currently configured to deploy to my GKE cluster, and I want to migrate it over to the EKS cluster. So I am going to make that change here and commit that. I'm going to call this migrate to EKS, and I'm going to commit that to that branch. While that is updating, we'll take a look here at the infrastructure group, and in particular at the AWS group. And similarly here, I can see increase the max capacity of the cluster. Again, it's an open issue. It's been assigned to me. I'm going to pick this one up by creating a merge request that's empty, and my team can see me collaborating it. Similarly, I'll open up the web IDE here again. And in this case, I have some Terraform code that's defining my cluster. And like I said, we'll go through this in a bit more detail, but here is the area where my node groups are defined as code. And so in order to increase the capacity, I'm going to change this from 3 nodes to 5 nodes. And I'm going to say increased capacity to 5. So I'm going to commit that change, and we'll be able to see that on this MR here. Now, there's a few things I want to do before I assign this back for review. The first thing I want to do is, you can see it's a draft, and it won't be able to be merged as a draft. So because I think the work is done, and it could be merged by my somebody who's got merge rights, or once it's approved, I'm going to mark it as ready. And that's going to resolve the, it's going to take away the draft notification. I am going to ping my manager, Brendan, and say, can you please review this MR? But here I could even ping groups, like if I want security to review it and I don't know exactly who in security, I could just ping a security group, or I could loop in other stakeholders. So here we're showing this is kind of the power of doing this change as a merge request, because you have this point of collaboration to discuss and show what's happening. I'm going to assign this MR to Brendan to review. And then I'm going to do the same thing with my EKS MR. I can see that here I have some changes and my pipeline's kicked off. I'm similarly going to mark it as ready. I am going to comment and assign to Brendan. Can you please review this MR? And I'm using a quick action here to assign to Brendan. I'll comment on that. And then I wouldn't want this MR to get merged first without the capacity being increased. So what I'm going to do is I'm going to set a merge request dependency. And I'm going to set my infrastructure MR as a dependency for this MR. So that way, even if this gets merged or won't be able to get merged until the infrastructure is first prepared, and then the application can actually deploy to it. So with that, I've done my work. I've assigned it to my manager. let's take a look at Brendan's view of the world as he goes to review the work I've done.
Great. Thanks, William. So as William said, now I'm going to come in and review the work that he completed and make sure that it meets all of our standards and actually solves the problem we were trying to solve. And so first, I'll go to my merge requests here. And here we can see the resolve increase max capacity of the cluster and migrate this app to the EKS cluster. So that's the thing I'm worried about. So let me click on that one first. I've got pressure to get this migration done. And I can go to this one. Well, I see this merge request actually depends on another merge request being merged. So that dependency structure that William set up was really important for me to understand. Oh yeah, that's right. We've got to increase the capacity of the cluster before we merge and move that app over. So if I look at the increased max capacity of the cluster MR, we can see here that their pipeline's passed. That's good news. But also I see that a Terraform report was generated for this pipeline. So this is our HashiCorp Terraform integration where that change that William made, the Terraform plan was run, and then we can see the output of that. So if we expand that, we'll see that, oh, actually, reported resource changes is 0. There's no changes, nothing to add, nothing to delete. Well, so even before I look at the code, I can know, hey, something's not quite right here. We wanted to change the capacity and nothing changed according to Terraform. So let's take a look at William's changes and see what might be the issue there. Okay, so I'm looking at this change and I see that he's changed the desired capacity, but not the maximum capacity for our cluster. So of course, our cluster is going to manage auto-scaling through Kubernetes autoscaler, right? And so that's going to tell it how many nodes do we need running at any given time to deal with the pressure of all the various apps that we're running. But they'll only go up to the maximum capacity. So that's actually the thing that we wanted to increase here rather than the desired capacity. So I'm going to add a note to this line. And actually, I'm going to comment on both the line above it and this line. I'm going to click this button to insert a suggestion. So here's where I can make a direct code suggestion to William and say, we actually want this to be max capacity from 5 to 7. And we'll say Kubernetes is going to handle the desired capacity. We want the max capacity to be increased. So that way I can click start a review here and it's now got that comment pending and I can review the rest of the file. It looks like there was just a little change with new line at the end of the file. So everything else looks good on this, but I can submit this for review back to William. And then once I've done reviewing that one, I can actually go and review the app change as well. So that is this migrate this app to the EKS cluster. So let's take a look at what that change looks like. And we can see here that's a relatively simple change of changing the environment from GKE to EKS production. So that one looks good. I'm going to go ahead and click approve on that. And I will reassign that one over to William. Just with this quick action. And actually just remembered I didn't assign that other MR to him. Oh, I can get right back to it here from the depends on. Okay, great. Let me reassign that one to him as well. William, great. So now I've reviewed both of those MRs, approved one of them, added a suggested change to the other one to make sure that it meets the criteria for closing this issue. And I've reassigned it to William so he can take a look and see the suggestions I made and keep us going. William?
Hey, thanks a lot, Brendan. So part of the beauty of this workflow is while Brendan and I are working on this in real time, this type of workflow can be done asynchronously. This type of change management and approval doesn't require you to be on a call or in a meeting. This is all done via comments and could happen live like I'm doing with Brendan if we were pairing, or he could leave a comment. I could see it the next day if we were in different time zones, if he was in Australia and I was in New York. All of this works whether you're in the same room or whether you're separated by an ocean. So I can see that Brendan has assigned everything back to me, and here I am in the resolve the max capacity, and I can see that in the review he has a thread. So this could have 1 or 10 or many unresolved threads, and I'm going to go and look at what is the first unresolved thread. So here I can see there's a nice comment from Brendan, who's a more senior engineer, maybe understands a little bit more, and says, oh, the Kubernetes is going to handle this desired capacity. We want the max capacity to be increased. So what's nice about this GitOps workflow is you have some training and coaching and mentoring where your senior engineers can provide guidance and insight during that code review. It's not just a matter of approval, but this is increasing your ability to train and duplicate your best staff by doing this type of code review the same way you would do an app dev doing it for infrastructure. What's nice here is because he's offered a suggestion, I can just click apply suggestion, and this will make a commit to this branch to make that change. So I can see in my commits, it's applied that change. Now in my changes, I can see the max capacity is set to 7, and I can see that all the threads are resolved. So with that, it looks like this MR is now ready to merge, and I can fire it back to Brendan, and I can say, Brendan, thanks for the review. This should be good to go now, and assign it. Brendan's already signed, but I'm just gonna leave him the comment to let him know that it's back over to him. And I'll look over also at my migration app. Now, this one still has the pipeline running a little bit, but we can see that it has a review app. It's now running our DAS security. So it's almost through the pipeline. I can see that Brendan approved the code changes. So I can click this merge when pipeline succeeds. This is really nice when I'm still running tests. I know this is ready to go. I'm saying, I just want to touch this once. Actually, here it tells me the merge failed, of course, because I have a merge dependency. So if we merge this one when the pipeline succeeds, no, actually this one failed as well. Let's try one more time. My apologies. I think I didn't refresh my page. So if we look here, this one has passed. I should be able to merge the capacity, and nothing like a live demo, even though we're recording. This is, of course, still a live demo for AWS. So you can see now that my max capacity cluster has been merged, and we can now go through and do a merge when the pipeline succeeds. But of course, the other merge needs to go through first. All that's to say is you can see the workflow going back and forth. This is going to continue to run a pipeline. And what we want to show you now is we want to show you what those pipelines look like. So let me first show you the infrastructure pipeline, and then Brendan can go through and show you the application pipeline. So the first thing, as promised, you saw the workflow go back and forth, but let's just take a look at a little bit of the code. So here in my AWS infrastructure project, here I have a few Terraform files. We saw previously the EKS file that we've been working with, but I have a few other files in here, things to set the back end and some cluster administration to connect this up to GitLab. And then here's my pipeline for the AWS branch. You can see it's just 2 lines. And what I'm leveraging here is I'm leveraging the ability to import a template pipeline. So that way I don't have to mess with various clouds in a multi-cloud environment. I can just have one pipeline that says go and enact the Terraform changes, and then whatever Terraform I have in that project is what's going to run in this pipeline. So let's just take a quick look at that templates project. And here is the template pipeline where I can see I have all of my settings set to cache my Terraform state file. So of course, this is a nice feature where you have to store your Terraform state somewhere. And normally you might need to set up a separate server to do that. But within GitLab, you can just cache your Terraform state file by adding it as a cache, and then it'll be accessible in between pipeline jobs. And you can see that we have these validate, plan, apply, deploy, and destroy stages where if I want to shut it all down, I can destroy the infrastructure as well. And essentially within the merge request, it's going to run the Terraform plan. And within the production, it's going to apply on the master branch. So if it's a merge request branch, it's going to do plan, and it's going to apply. So you saw the pipeline on the merge request branch. It was really simple. It just ran Terraform plan. Here is the pipeline for the infrastructure. Here I plan the production, I do a Terraform apply, and then it's going to use a child parent pipeline to actually run some code that is in the apps repository to go and do the EKS installation. So that's a look at the infrastructure side of the pipeline. Let Brandon walk you through the application pipeline.
Great, thanks, William. And like you said, nothing like doing a live demo. But luckily, I have a completed pipeline here to show, so it'll be easier for me. But I wanted to take a look, as William said, after all that infrastructure is together, what is GitLab doing to deploy the application? As we saw in the code walkthrough, it's relatively simplistic CI configuration, right? William didn't have to do a whole bunch of changes to the CI to get it to deploy to a new environment. And the reason for that is what GitLab calls auto DevOps. And so a lot of what we're leveraging here is the auto DevOps template that comes with GitLab. And with that comes not only the ability to deploy to any Kubernetes cluster, but also a lot of test jobs that we can see here that come automatically just with any time we push new code to the application. So here we can see it's running code quality. So this is running code quality scans. Well, we're running container scanning. The container we create, do any of the layers in that container have, a known vulnerability? We want to know about that. We're running, of course, lint and all kinds of Node.js tests and unit tests, rather. And then we're also running secret detection and license scanning. These secret detection looks for, did you accidentally, put your AWS key in this commit? We want to make sure that you don't accidentally commit secrets to the repository. License scanning ensures that, if you're bringing in a lot of open source dependencies to your application, do any of those licenses conflict with the license that's going to end up in your application? And then this review app pipeline published a review app. So this was a fully running version of the app inside of Kubernetes for us to review. That way we could make sure all the functionality works exactly as we expected and review the app in Kubernetes, just like we would review the code, right? So I was the engineering manager reviewing the code changes that William was making. We may have also had a project manager or product manager who was able to review the app itself and make sure that it was going to work as intended once the migration was complete. And then we'll also run some dynamic application testing. So once that application is stood up, the review app exists. Let's run some dynamic security scans against it to make sure there aren't any vulnerabilities that we can find. And also performance testing. How have we impacted the performance? Of course, this could be really critical as we're working on tuning, what's the size of our cluster, what's the capacity we want versus the app performance we need. And then finally, just to show the completed production pipeline, once we had merged that all in, we ran a lot of those same tests again, but of course, then we deployed directly into production. So that's how Auto DevOps and a lot of the templates that are built into GitLab helped us do this migration a lot simpler than it would have been to hand code all of the changes between two different providers to get our app migrated into the AWS cloud and into AWS EKS. And with that, William, I think you'll take us home with a little bit of a summary of what we've learned.
Thanks a lot, Brendan. If we look here, these are the key takeaways for the session. You can find all of this example code in this Chia GitOps demo group that we've set up. You can go and look through it and see everything we've done. At its core, GitOps is a methodology for managing your infrastructure as code. It allows you to collaborate with peers and stakeholders, and it gives you built-in compliance and auditing because you can see who made changes and what changes were made in the Git log. At its core, GitOps really just requires just three components: infrastructure as code, merge requests as your agent of change, and CI/CD automation. With that, we want to just say thank you very much for watching. We're looking forward to engaging with you in social media. And please do remember to complete your AWS survey and rate 5 stars if you enjoyed the talk. Thank you so much.